All right, so to review, law of sines, law of cosines, we've already done this first example. Law of sines and law of cosines are used on non-right triangles. Remember, you can't use SOHCAHTOA in a non-right triangle. It's not an option. You can't use the Pythagorean theorem, also not an option, because those only work on right triangles. So non-right triangles, there's law of sines, law of cosines. So how do you know when to use which one? Law of sines you use when you have a known pair. This means a side and an angle that you know both values. If you don't have a known pair, you use the law of cosines. And there's a pattern to the formula, but it could be a squared, it could be b squared, it could be c squared, and the pattern would follow. But how do you know which one to use? You know it based on your given angle or your missing angle. So missing/given angle. So whatever angle you're trying to find or what angle you are given, you're going to set up your equation using that letter, A, B, or C. So what you want to ask yourself to start, do I have a known pair? So in this first example, I have three sides, I don't have an angle, so I don't have a known pair. So I'm going to use the law of cosine so that I can find a known pair and use the law of sines. Remember that to solve the right triangle, we're going to end up finding every missing piece, which here means the measure of angle A, the measure of angle B, and the measure of angle C. So let's start with the biggest angle. So remember that sine to the negative 1, the inverse, can't find obtuse angles. Okay, so you can't later on expect to use sine, law of sines, to find the measure of an obtuse angle. So you want to find the biggest angle first to ensure that if it is an obtuse angle, you find it correctly. So the longest side is 30. The biggest angle is going to be A. So we're going to find A first by using the formula. Sorry, I gave myself some room. A squared equals B squared plus C squared minus 2BC cosine of angle A. So we can label the sides so you know where they're coming from, but A is across from 30, so A is, side A is 30, C is 18, and B is 27. So we're going to plug them in, starting with A is 30, 30 squared, okay, and then equals B, which is 27 squared, plus C, which is 18 squared, okay, minus 2 times B, which is 27, times C, which is 18, and cosine of angle A. All right, so starting easy, 30 squared is 900. And remember that some of these you can just plug directly in your calculator, like 27 squared and 18 squared. It is 1,053. And then you can plug in that minus 2, negative 2 times 27 times 18. We get negative 972, and then still cosine of angle A. Remember that you can't combine these two numbers together because negative 972 is attached to cosine. It's being multiplied times cosine. So we can't subtract these. What we can do is move that 1,053. We will get a negative number. So the thing that I'm seeing the most is students make mistakes on forgetting about negatives and positives. So it will drastically change your answer, unfortunately, if you don't either keep the negative, like in this case, we're going to divide by negative 972. You and I both know a negative divided by negative makes a positive, and it will change what we type into our calculator. So we want to get A by itself, it's attached to cosine, so we're going to need to do the inverse of cosine of 153 over 972. So shift cosine. 153 divided by 972, and we get 80.9. So that was A, 80.9. Okay, this is a case where if you want to ensure the absolute correct answer, you don't round. So here's what I mean by that. Yes, round it when you write the answer out, but whenever we go to plug it in and use it as a known pair, you don't use the rounded answer. So give me a second and I will write it. 5, 2, 2. Okay, I know it's not pretty, but we have a known pair, and now we can find the remaining angles using the law of sine, because now we have a known pair. So we want to use A. Again, the law of sine can't find an obtuse angle, so I would always just find the smaller angle at this point to ensure that you're not finding an obtuse angle. Now I'm 85% sure this is not an obtuse angle, but if it wasn't drawn accurately or to scale, then we might be solving for, the wrong thing. So, find the smallest angle, be across from the smallest side next, so that when we plug it in, we know for sure we're getting an acute angle. So I'm going to find angle C using side C, but remember what's missing goes in the top. So sine of angle C over side C equals, I'm going to use my known pair. So sine of angle A, this is when it's a little obnoxious, sine of 80.9435552 over the side, which is 30. Sorry that I wrote side C instead of the number. It's 18. That'll make our lives a little easier. So now we solve. We want to get sine of C by itself, so we're going to multiply by 18 first to cancel out that fraction. So sine of 80.9435552 over 30 times 18. And you get a decimal. You don't have to write it down. I'm just writing it down so you can see what I see in my calculator. I'm going to shift sign of your previous answer, and it is 36.3. At this point, we have two angles in a triangle. We can find the third by adding them and subtracting them from 180. So 180 minus 36.3 and 80.9. Also the nice thing in your calculator, it's a scientific, you could just type in both instead of adding them and subtracting them. All of it, either way is fine. It does not matter. But either way you get 62.8 degrees. All right. Looking at the next one, do we have a known pair? We do. We know 85 and 9, so we have a known pair. So we're going to use the law of sines first, but even easier than that, we want to find the measure of angle C, we want to find the length of BC, and we want to find the length of BA. Even easier than that is to find angle C by subtracting from 180. So 180 minus 85 minus 29, we get 66. So now we can find either of the remaining sides using the law of sines. So I listed BC first, so why not? It's A over sine of 29 equals, you want to set it equal to your known pair. So 9 over sine of 85. Multiply both sides by sine of 29. 9 over sine of 85 times sine of 29. We get 4.4. We do the same thing to find BA. C over sine of 66. And then use the same known pair. equals 9. I'm just going to literally rewrite the known pair. 9 over sine of 85. Multiply both sides by sine of 66 to cancel out that fraction. 9 over sine of 85 times sine of 66. We get 8.3. All right, letter D. Do we have a known pair is what you want to be asking yourself. And no, we don't. We don't know the angle, we don't know the angle, and we don't know the side across from our angle. So we're going to use the law of cosine. We're going to find the measure of angle C, the measure of angle B, and the length of CB. Not necessarily in that order. But this is the angle we're given, so we're going to find CB first. So a squared equals b squared plus c squared minus 2bc cosine of angle A. This is the one we like to do because we just plug everything in. B is 23. C is 26. Minus 2 times 23 times 26 cosine of 114. Sorry, I ran out of room. So 23 squared plus 26 squared minus 2 times 23 times 26 cosine of 114. We get 1,691.4570025. Square root of the answer, 41.1. So again, when we write it in our answer box, you can round it, but I would not round it to use it as a known pair so that our answer can be exact. So here's our known pair. Let's find one of the angles. Again, you want to make sure you're using an acute angle. It does definitely appear that both of them are acute. They have to be if this one's obtuse. So it doesn't matter which one you find here, but if you want to stay in the habit of finding the smaller one, we can find B first. So remember, we're using law of sines, so sine of angle B over 23 equals sine of 114 over 41.1273269 times 23 sine of B. Again, you don't have to write this decimal down, but if you want to, shift sign of your previous answer. And the measure of angle B is 30.7. Now you know two of the angles in the triangle. We can find the third by subtracting from 180. So 180 minus 30.7 minus 114. And we get 35.3 degrees. All right, last thing we do is find the area. Remember, this formula is super simple. Area equals 1/2 times the side times the side times sine of an angle. So 1/2 times the sides, so that'd be 14 and 9, times sine of 79. Type it in exactly how you see it, and we get 61.8 units squared. Yes, you absolutely have to put units squared. I'm telling you, when you get to this PERT test, it is going to make sure that you know the area is squared. Okay, so you've got to make sure we're in practice right now. So area is squared. Same thing with the second, 1/2 times the sides, so 22 and 19, times sine of 24. Type it in. 85 units squared. Perfect.